Hi everyone, welcome to Easy to Learn channel. Today I am going to explain about classification of signals. So in previous video we have seen what is a signal and what is a system. So we have different types of signals. The first one is a continuous and discrete time signals. And the second one is analog and digital signals. And third one is periodic and aperiodic signals, even and odd signals, energy and power signals, deterministic and random signals. So all these are the different 6 types of signals. Let us see one by one. The first one is a continuous and discrete time signals. Here the continuous signal is nothing but the signal which varies continuous to time. So it is also known as an analog signals. That is nothing but here the signal is nothing but this is the signal, analog signal or a continuous signal. The signal here which is represented x-axis is t and y-axis is some which is nothing but amplitude, which is represented as a x of t. So this is a continuous time signal. So whereas discrete time signal is nothing but the signal which varies only at regular intervals of time. That means discrete or regular intervals of time. That means, so this is a discrete type of signals. These are discrete intervals, that or we call it as discrete instants of time. These are discrete instants of time. So this is represented as n and this is represented as x of n. So this is a continuous signal. This is a discrete time signal and this is a continuous time signal. So here the discrete time signal can be obtained from the continuous time signal. How to get from continuous to discrete? So one is sampling technique. So if you apply a sampling technique, it converts from continuous to discrete signal. But here the discrete signal is not an analog signal. The discrete signal is not a digital signal. What is the second type of signal? Here is analog and digital signals. Here the analog and digital signals are nothing but the analog signal is nothing but this is the analog signal. We call it as a continuous time signal. Both are same. But here the digital signal is not a discrete signal. Here if we convert from analog to discrete means we are applying sampling technique. Here the digital signal, the digital which indicates what? Zeros and ones. That is nothing but high voltage or low voltage. Here there is a discrete sample cell. For every sample there is a sum n is equal to 1, n is equal to 2 and so on. But here the digital signal which only contains the two numbers 0 or 1. So here the digital signal, this is a digital signal. For example, this value is high 1 0 1 1 0. But these two signals are not same. So we are converting from continuous time to, or we convert from analog to digital signal. So analog to digital signal is nothing but what? So we are converting from analog signal to digital signal. We are applying, one is, first we have to convert from analog to discrete signal. After that we have to convert discrete signal into a digital signal. From one of the process, that is nothing but a signal that is discrete in time but quantized in amplitude is called a digital signal. Here the quantization is a process in which each sample is round off to the nearest fixed quantization levels. That means, so after sampling, after discrete converting into a discrete time signal, we are applying here a quantization technique. Here the quantization. That means after applying the quantization, we can get a digital signal. So the two different techniques are what? One is sampling and quantization. These two are the different techniques from converting from continuous to digital signal. So this is the second type of signals. The third type of signal is The third type of signal is periodic and aperiodic signals. So here see periodic and aperiodic signals. So here the periodic and aperiodic signals are nothing but what? Here the periodic signals are nothing but a signal is said to be periodic if it repeats at regular intervals of time. That means, for example, if you take a signal, so this is time period t and this is x of t. So from here to here is a time period t. So from here to here is t. So after completion of this time period t, again the signal is repeating. This signal is said to be a periodic signal. What is a periodic signal? The signal which does not repeat after certain interval of time. That means, see this one, this is an exponential signal. This is an exponential signal. So here this is t and this is x of t. This is an exponential signal. The signal, is it repeating? No, it's not repeating. So this is a periodic signal. So that means example is a school bell or a college bell. See, for every hour there is a 40 minutes of time. After 40 minutes or 50 minutes or 1 hour, after every 40 minutes the bell again ring. So that means the signal is repeating for every 1 hour or 40 minutes or 50 minutes. Again the signal is repeating. That is a periodic signal. So here a periodic signal, the signal is not repeating at regular intervals of time. Okay, that is a periodic and aperiodic signals. So fourth one is even and odd signals. Even and odd signals. So here the even and odd signals are nothing but, so here, so in previous periodic and aperiodic signals, there are number of problems on periodic and aperiodic. We have to see in the next video. So one more, one of the most important in periodic signals is the condition of periodicity. So the condition of periodicity is nothing but x of t is equal to x of t plus capital T. So this is the condition for periodicity. So that is nothing but t is nothing but, this is the time period, and capital T is nothing but for one cycle. So this is the condition for periodic signal. So this is very, very important. And next one is even and odd signals. So here the even signals are nothing but, the signal is said to be, if it is an even signal, the inversion of time axis does not change the amplitude. That means here there is one condition, that is for even signal I am representing as xe of t is equal to x of minus t. That means inversion. For example, if you see, so we have 4 different quadrants, right? This is, for example, t. This is, we are getting here the what is the values, positive values, right? Here what, negative values. So here is what, minus t, right? So on y-axis what we represent, amplitude, that is nothing but x of t. So here is positive values, we are representing x of t, and what is this one, minus x of t, that means negative amplitude, right? Now let us see the condition for even and odd signal. So here this is the condition for even signal. Now what is the condition for odd signal? xo of t is equal to minus of x of minus t. So the signal is nothing but inversion of time axis, also inverts amplitude of the signal. So that is condition of odd signal. So here how to represent, this is a continuous time, how to represent in a discrete time, xe of n is equal to x of minus n. How to represent discrete time, xo of n is equal to minus x of minus n. So these two are the condition of continuous time as well as in discrete time. So let us see one example on this even and odd signals. Let us see even and odd signals. So here first the even signal. If you see the even signal, even and odd signals. So for example, how to write this one? X of t is equal to x of minus t, and odd signal is what? Odd signal is x of t is equal to x of minus t, minus x of minus t. So this one is even and this one is odd signal. So how to draw a how to represent this signal in a diagrammatic representation? For example, there is one signal. So there is a signal here. This is the signal. This is t and this is x of t. So we have to represent this signal in terms of odd, in terms of even and in terms of odd signal. So this is x of t signal. So here how to represent x of minus t signal? So this is a t. That means how to represent minus t? So this signal is here the folding version of the signal. That is nothing but inversion. So this is the signal. If you fold this one, how to get this signal? This is inversion. This is x of minus t and this value is what? Minus t. So the same signal if you represent in odd form, same signal. First this is x of t. So this one is what? Even signal. We already represented that signal x of minus t. Now we have to invert the amplitude. That means, so after the first part of this one is from we have to convert x of t into x of minus t. After that we have to convert minus of x of t. So minus of x of t is nothing but what? Inversion. So inversion is nothing but what? So we can get the signal. So here we can get the signal like this. We have to invert the amplitude. So this one is what? X of t minus of x of minus t. This is odd type of representation. So if you take any type of your signal, for example, if you take a rectangular triangular signal, this is t and this is x of t. So how to represent this signal? So we have to, this is x of minus t, and next the folding version is what? The inversion version of amplitude, minus x of t. So this one is even and this one is odd. So remaining two signals we have to see in the next video. If you like my video, please share, like and subscribe. Thank you.